Over the past few years, we have seen huge progress in AI, but robotics is still a very different challenge. It's not just about intelligence, it's also about building the physical systems that can operate in the real world. So today, we will talk about where robotics actually stands these days and what it takes to build a company in this space, especially from a region like Central Europe. So I'm joined with Benedek Tasi, co-founder and CEO of Allonic. Hi Benedek, nice to see you.
Nice to see you too.
Before we go deeper, just really simple words. When we are talking about robotics in 2026, what do you mean about that and how do you describe this industry?
Well, that's a very, very broad question. So we're living in an age where embodied AI is definitely shooting at the forefront, and we're seeing more and more applications. And I think maybe the most important thing to mention about this is that we are really nearing that tipping point where this will become something that is broadly accessible and applicable. And we're seeing more and more applications out there where this is becoming reality. And so it's a very exciting time to be moving in.
Okay, but what do you consider as a robotic product?
In the modern meaning of it, we definitely mean intelligent systems, but in a traditional sense, everything from the factory floor that is capable of automating repetitive tasks. So I think today, both of those are still meaning the same thing, and both of those can definitely be considered robotics, and the intelligent systems part is definitely entering the scene. And as we see more and more humanoids and assistive robotics, and etc., it's becoming the new reality.
Yeah. What about the industry? How big is this industry? Do you have any
it's huge.
numbers?
Yeah, so well, I'm not the numbers guy in this case, but it's a multi-billion-dollar industry for sure. So it's projected to reach multiple tens of billions by the next couple of years. Usually the ballpark number is 2035. And that is because of the advancement of physical AI and humanoids and the whole capability of automating not just repetitive tasks, but tasks in unstructured environments as well.
Okay, now let's start about your background, your origin story. So how did you become involved in this robotic business or bioengineering? Looking your background, what was the inspiring thing?
So I come from a field of biomedical engineering. I was studying bionics, and I was always interested in both of the medical part of it and both of the engineering part of it. So like the hybridization of these systems. And in my case, the interest came from how could we create robotic systems that adapt better to our environment or to our bodies in the case of, for example, prosthetics. So as a biomedical engineer, I come from researching prosthetics. And I think that is a perfect example of robotics that need to adhere to very strict and very meticulous user requirements, both in terms of integration, in terms of psychological relation, in terms of naturalness of movement. So I was always interested in making this easier or better. And now we are starting to see the same needs arising from more industrial applications where robotics are leaving the factory floors and getting integrated into our daily lives.
Okay, and along the way, most of the students just finishing university and having a nice job and starting to work. Not in your case. So you, for some reason, you decided to create your own company. What sparked this idea?
I think when you really start working on a problem and you, from day zero, see like a mode for yourself, you see problems that need to be solved, like you see glaring omissions in how systems work, then it creates sort of a motivation to okay, let's try doing something about it. And I was very lucky to be in an environment and among peers who were thinking similarly. So we ended up. It was never like an arbitrary decision to start a company. It was more like, okay, how can we actually solve this problem of creating more natural robotics, first from a prosthetic angle? And the short answer is that in this universe, there is not really another effective option. If you really want to get your technology out to people and solve their problems, then starting a company. So it kind of made sense from the first day to move towards the startup ecosystem.
Okay, and did you get any help during this path or at the beginning of this path that you founding your own company? Anyone who helped you or institutional help, or just it was you and your friends?
Yeah, so we definitely were very lucky in the sense that where we're sitting here is Pázmány, the Information Technology and Bionics faculty, and they definitely helped us, like left us to to do our thing and didn't force us to take different pathways and kind of we were able to sit in an environment and onboard students and work together and start building something without a very, very clearly defined goal at first. And then when that goal became focused, then something that definitely struck ahead. So we definitely have a lot to thank for ecosystem that allows you to do this. Usually it's much more academic and restrictive.
Okay, so you started Allonic and building a robotics hardware company anywhere in the world sounds a bit difficult. What about that you started to build this company in the Central Eastern European region, especially in Hungary? How was this journey? How did you see it?
So we never really considered ourselves as a Central Eastern European company or anything of the such. To be honest, we never did care about such monikers. We never did care about location consciously from the get-go. We've been working as a research group for 5 years. We've been building an international network. We've been there at the US market. We've been there at the European market. So in my perspective, it doesn't really, unless you make that your identity, it doesn't really matter where you come from. There are certain advantages and disadvantages to location, geolocation, but that's about it. So in this case, in terms of building hardware, in terms of building a huge team and a very innovative company, it definitely helps that the cost of living is still lower in this region. And as long as you have, so Hungary, for example, has a pretty nice talent pool for most of the things we need. We can definitely hire internationally. We're lucky to be sitting in the European Union and in a world where travel is rather easy. So I'm not seeing that as restrictive in this sense. So I would say that we didn't really have much of a difference in this case, and that comes down to us not owning this fact as a restriction. Usually it amounts to like there's a certain ecosystem in this region which kind of teaches you that it is harder to start from here, but we didn't necessarily know that, we didn't necessarily care about that, and I think our story shows that that is not a circumstance you really should worry about.
Okay, but you mentioned it was a bit harder, so it's not the same that you were like, I don't know, a US company or in Germany.
I don't think that's actually true. So it was definitely harder in a sense that, but it's pros and cons, right? So from certain aspects, yes, it's harder. We're not sitting in the biggest robotics hub in the universe. Like we're not sitting in Zurich, we're not sitting in Silicon Valley. But then again, because of what we did, we definitely stood out even in the valley when we went there. So the point is that if you're one of those regions' companies, you're just one of 1,000. If you go there with being successful externally from such a region as us, I think that's a big bonus. It doesn't make it harder, it actually makes it better.
Helping hands along the way from institutes, organization, or personal mentors. How do you see that?
As we started, so originally we were very much in stealth, and we had this organization, the university where we're coming from. We were slowly building our network, professional network in the academia and industry, and that helped a bit, but we couldn't really rely on it a lot because the technology wasn't public yet. So it's a little bit difficult to to do that and be in stealth. But since we revealed this in last May, we've had a vast growth of network and a lot of mentor figures and helping hands, and that comes from professional background, that comes from investment background, and then a lot of different areas where we've been helped to make this story a reality. So yes, of course.
How do you see the local robotics, or let's say deep tech ecosystem here in Hungary? Is that a thing that we can say, or it doesn't even exist?
I don't think so. I think it's a new thing. I definitely think, and our experience shows that it is a new thing. It's the local region, and Hungary was sadly never too quick about catching up on new trends. And now we are realizing, and I'm very happy that Allonic is a story that kind of show this and be a little bit of a pioneer in this sense to show that, okay, deep tech is also here. Robotics is also here. It is possible. Hungary doesn't need to restrict its startup environment for software, especially in such a world where software is devalued by AI and hardware is getting to the forefront. And I think we are definitely seeing a shift in this local ecosystem as well. We are in the early stages of it, but I'm hoping that, especially as seeing that what we managed to do in a pre-seed stage, that will encourage other builders as well to get out and show themselves to the world and show Hungarian deep tech to the world.
If anyone seeing this video who is considering to start some company on their own or has some idea in the hardware field, would you give any advice or encouragement for them to
do it? So it's like, I think the biggest advice is just, every story is different, and in our case, my biggest advice would be that to don't follow standards. I think my luckiest break or our biggest chance in the story was given by the fact that we never enlisted into any official programs. So we were a new thing when we came out. It's an innovative idea where we really struck a nerve, where we really found the problem that we were struggling with for years, and that is what we are trying to solve. So we really feel it as our own problem and our own pain as robotics builders. And we managed to enter the ecosystem completely from stealth, and that had a power. That had a power of showing who, when we shown who we are, that was a new thing, and that was a novel approach and a novel entrance to the field. And so my advice would be is to use your novelty and your ideas and what you discover to your advantage, instead of trying to, like, a lot of startups try to get ahead by moving incrementally and slowly and steadily finding their moats. And I think that, so it's to each their own, and that could be a very, very good way to get forward. But in our case, the best scenario was made from the fact that we only came to the public eye, or in front of the public eye, when we actually already had something.
Okay, but it's, on the other hand, it's maybe sounds a bit harder than you cannot get any
exactly, and that is why it's not true that you cannot get any help from the outside. That is why it's a difficult thing. So there is no, like, we faced this quite often when we were starting out, that okay, we require a boost to start from, you know, 0 and get to 1, and you're not going to get that. So the advice is to try, and we had the luck to be in an ecosystem where we could build. We had a lab at the university, so I would say that finding a good team and finding an establishment that you can do something is actually definitely one of the key requirements. But besides that, in terms of capital, in terms of starting to build, in terms of an idea, there is no recipe. So the only advice I can give is that you have to go out and have to do it. And I think maybe the biggest importance that we did was that we didn't get stuck in academia. We went out and started talking to people as soon as possible, as many of them as possible. And that is the biggest factor that will influence your product direction and decision when starting a company. Without that, with just building on your own ideas and environment and cues, that is not going to be enough.
Okay.
Yeah.
What were the biggest obstacles at the beginning when you started?
Quite a lot. I think in terms of hardware and like building a hardware company, it's always the lack of capital. So that's the Hungarian ecosystem actually helps in that, because you learn to to get by on very little and use that to build something. So I would say that the biggest obstacle that is not actually for Allonic or not actually for companies, but the Hungarian ecosystem needs to overcome if they want to have deep tech, is capital. So what I must say is that our round, while being a record-breaking pre-seed round in the area, is not a big one. And that is a very important consideration, that in order to have innovation, you need to put the capital forward. It will not happen without that. It will not, especially in deep tech and especially in robotics, capital needs to come first, and revenue and etc. comes at a much later point. And unless the ecosystem recognizes that this is no longer a business case where you get a very little capital injection and then revenue immediately starts flowing and you build incrementally, it simply won't work.
And why do you think is that there are no history of this in Hungary, or the institutes or the venture capitalists doesn't realize that this is the different?
No, I think this is a new direction, and now they are. So now they are really, that is how we could do this as well. But there's definitely some catching up to do in this sense to the West, where this has been happening for a good number of years now.
Coming back to robotics as an industry, what do you see? What are the biggest problems in this industry that companies like Allonic can solve?
So obviously, the reason why I'm sitting here is because I think one of the biggest problems is scaling. where you actually need to get. It's amazing to have a variety of robotic products out there. It's amazing to see like hardware becoming something of a commodity, but it's still not going to be true for customization. So in terms of humanoids, for example, the reason why everyone is shooting for massive scales because such a complex hardware is only feasible on massive scales. Otherwise, the unit economics will not make it. And therefore, finding and that is a limitation because you are not allowed to explore new solutions easily. So in terms of using a humanoid form factor and using products out there, sure, that becomes easy. But if you have a need for a specialized solution for various examples or industries where simple generalization is not necessarily enough, that is a quite difficult thing to grasp today because you don't have the ability to very quickly start with a completely different hardware design other than generally available components. And therefore, one of the biggest challenges is to make that possible, and that is what we're working on with Allonic. And I think maybe the most important part of that even is that as robotics start to enter our workplaces, or maybe our homes one day, or general lives, it becomes increasingly difficult to do so because if you need safety, if you need softness, if you need even more dexterity, you start stacking technological layers on top of each other. And each layer makes your hardware and your software and so your full stack more complex. And that doesn't scale. It will always require really complex assembly, numerous material technologies. Even if you have humanoid robots building humanoid robots, it still requires huge amounts of capital, like a hangar of humanoid robots building humanoid robots. So there is a lot of room to make that even more scalable. That is what we're working on. And on the other side, of course, manipulation and dexterity and that level of interacting with the environment that we want to see in our intelligent robots is still not there. And it's still something we are working on, but that field is advancing insanely quickly. So that it is very exciting to see. I think the translation of that into human-safe environments is something that is going to be a little bit more difficult. And that is also why we're super excited about our technology with Allonic, because that is something that inherently makes that possible.
Okay, and how can you solve this scaling problem with Allonic then?
The simple way is that instead of having to build out completely different supply chains and technological stacks for each layer we mentioned, we condense all that manufacturing into a single platform, which is basically the size of, I don't know, this area we're sitting in right now, or like a shipping container. And the whole idea is that if you have a little bit of a similar approach to robotics design and assembly than 3D printing, that means that you're able to configure your designs digitally and translate them into physical reality in an automated process. And by integrating every component level problem and every feature that robotics needs in terms of joints, tendons, springs, sensors, whatever, in a single production chain, which is fully automated, that basically eliminates your need to get this huge supply chain and assembly system going. And that would be the purpose.
These days, the hype word is embodied AI, embodied robotics. So how do you see that AI alone is enough to advance robotics, or
I definitely think it's the pulling force. So without AI, without embodied AI, it wouldn't be possible to create intelligent systems, and it wouldn't create this huge opportunity space for robotics to get forward. If you look back 5 years ago, there was not a lot of that out there. So obviously ChatGPT hadn't arrived yet in the form we see it now today. So there was robotics research and there was robotics development and there were robotic products out there, but it was very, very limited to repetitive, very structured environments on the factory floor. And the only way to get out from that is to figure out how we can manage variability, how we can manage environment where structure is not to be found, and that is what AI brings. So everything that we do, everything that the industry does today in robotics is thanks to that shift, which makes it possible, which makes it not, it makes it possible to think in intelligent systems, but even more importantly, it makes it worthwhile to think in complex systems. It's no longer advantages in every case to simplify as much as possible, because you lose function, and advanced functionality is something you can benefit from if you have the advanced software infrastructure and intelligence to make it.
do you use any kind of AI at Allonic as well?
Yeah, of course.
And what kind of tools are you using if it's public?
Yeah, so part of it is public, so obviously we use every single assistive tool we can find in coding. Cloud Code is amazing, for example. We also build a lot of agentic automated workflows to help us support our work. We are also exploring various avenues for, and that is a less public part of how we can make these very complex robotic systems we build and these various form factors controlled basically in various environments and various stacks. So yeah, it's a pretty integrated part of it. We are focused on the hardware aspects. So we are focused on the fact that AI technology and control technology is advancing so rapidly that the adoption of it should become very, very easy in a couple of years. It is already easy, but it's progressing insanely fast. And we want to be the hardware backbone for it.
Okay, and just to understand where Allonic is on the industrial map, so who are your customers? Who are you targeting, or in the supply chain, where do you position yourself?
So Allonic is an infrastructure player of the new emerging ecosystem, and what this means is that we are making it easier to create complex robotic bodies, essentially. It definitely has a high value if you focus on increasingly customer-oriented segments where we definitely directly interface with the robots. But even more generally, we are targeting problems where this level of versatility is useful. And what that means is that we are selling to industry members who would like to use this type of robots to solve their own problems. And down the line, we are looking to actually make the platform and the technology available. Think PCB manufacturing to create custom structures, or think mass production of similar custom design structures to robotics developers who want to make their stack easier or more compatible with the use cases we promote.
Okay, so it's flexibility, cost saving, or what are the main words when you talk about the customer?
Yeah, so I think a bit of both. So it's not about a couple of keywords which you increase. It's about a little bit of a different thinking towards designing hardware that we want to promote. Because if you have the ability to create completely custom hardware, which is really easy to iterate very, very quickly without requiring a setup of a huge supply chain and very, very cost effectively, then that means that you're no longer constrained to your early design decisions. You no longer think about manipulation or about robotic hardware as something that is very high quality or very expensive. You think of it something as where you can reach high quality basically from your back room, and that is something where you can create these systems that will integrate with your existing stock to your own image and to your own needs wherever you want to. You can throw them away, you can swap them, it's a little bit of a thinking where when you approach a covering, where you approach a glove for your robotic hand, if you want to apply it in different conditions, you just change the glove, right? And in this case, you just change the manipulator. And that is what we want to reach. So yes, both of those, but really it ushers in a new way of thinking about hardware. Same way that you think about software today, where it's completely disposable something. It's you develop your own app if you so need to. Now you have AI tools for that. You write your own code. You develop something in-house. We want the same to be possible with hardware.
With solutions like yours, we can say that that smaller industrial players has the chance to
absolutely
to play with the big ones,
absolutely
compete with them.
Yes, the whole point would be, and I think that's a very nice throwback to our original motivation, prosthetics, where it's still a huge affordability is still a huge problem. Like if you look at, there are already very advanced prosthetic products out there which are considered cheap, but even then it's 15K or something like that, and that is insanely expensive. Most of the products out on the market today are actually neighboring 30K at least, and that is a huge price for any kind of insurance setup or any kind of private person to pay. And the big reason for that is that the market, luckily, is not big enough to support insane scaling, which would push the prices down. But the product itself is complex enough and already heavy enough to push the prices up. So there is no balance. And if we can create a system which shortens your R&D time, shortens your production time, it makes production more cost effective and makes the end product, the hardware itself, more cost effective, more cheap at the end of the day, that can help actually push the prices down to an affordable level. And prosthetics is a good example for that, but there are several industries which suffer from the same problem, that the market in itself is not big enough to make scaling worthwhile. Even if you think about, like, even in the case of a big company, when you're a big producer or OEM or whatever, and you want to have a specific robotic solution for whatever need you have, and you want to go ahead and build your own thing, you can only make that scalable and easy to integrate in your own processes if you can somehow keep the cost low. Otherwise, it will be prohibitive. And with a technology like ours, it is possible from the get-go without having to scale first. And that means the smaller markets can be targeted and smaller players can enter as well.
Very good, very good. Fortunately, we just have some prototype here that you can show.
So this is a demonstrator hand. This is the first one we built with this technology, and the whole point here, this is a biomimetic one. So the whole point here is to replicate human anatomy as closely as possible, because what we wanted to reach here was a very human-like nature of movement. It was not fully about, it's about discourse manipulation, sure, but it was not about going the extra mile and demonstrating all the necessary degrees of freedom in terms of control. It was about getting those degrees of freedom in the similar synergistic way as the human body does, in order to have the same feel to the movement as we do. And this, because of the complexity of this challenge which we faced, that kind of led us to develop this technology that we now have. Because the original problem is that if you look at complex hybrid system like this, where rigid and soft components have their own synergistic interplay at all times, it becomes really difficult to build them together in a robust way. Usually soft tissues are fragile, and one of the key factors, load bearing, is definitely something that's missing most of the time. In the case of the human anatomy, ligamentous joints, for example, play a huge part in our ability to move with such efficiency. So a great example is this metacarpophalangeal joint, where you are able to do the tilting movement. If you flex it, it becomes stabilized and you're only able to rotate. So there are so many fine little details in our movements that you cannot, it's very difficult to replicate these with conventional robotics design. And therefore it makes sense to try and replicate the workings of biology, and ligamentous joints are an example of that. But there, it's a very specific example of how you want to merge. In order to do that, you want to merge rigid materials like the bones and soft materials like the ligaments, the connective tissue, the collagenous tissue, and the fascia of the hand. And the problem there is that in order to create interfaces, in order to create complex load-bearing soft tissues and create interfaces between the rigid and the soft elements, that is a very difficult problem, because you will always have a joining point, which will always be a weak point between the soft tissues or between the rigid and soft tissues. And that is kind of what our technology solves, because as we weave our soft tissue around the bones, it actually squeezes it together and it holds them together by its own nature, the nature of the rope making technology. And our fibers distribute loads across relatively huge surface area ratios. And what that means is that we don't have single points of failure. We have a huge impact resistance, and we have distributed forces over the bone surfaces, which makes the entire system stronger while being able to do very complex designs because of our ability to create everything like this automatedly. So that is kind of the trick here, and that is how this hand was also made.
It seems like really complex, but simple at the same time.
Yes, that is the exact purpose, is that usually if you go and increase functional complexity, your mechanical complexity also increases, and that will increase production and assembly complexity. And that is generally bad, because it makes scaling and engineering for production more difficult. And if you want to keep that low, and once you create a scalable product, you usually need to reduce mechanical complexity and you need to reduce functional complexity. So it's a circle. And in our case, we wanted to have a way to preserve mechanical and functional complexity, but still be simple to produce. And this is the way to do that.
How maintenance heavy is this thing? So you have to do maintenance oftenly?
Yeah, so that's kind of the whole point, is that with this case, this is a completely different approach. Usually you think about maintenance as something you definitely want to avoid at all costs, and you measure the life cycle based on that, because that causes downtime. It's a very expensive process to replicate, to replace the effector, or to fix the effector's parts. You have to maybe ship it to the manufacturer. It's a tedious part of your supply chain, and you usually calculate for margins of that. In this case, you think in a different way, because due to how cost effective it is, you don't care if this all gets damaged. You can have like a quiver of robotic hands at the back of your robot and with a tool changer and replace them on demand whenever you need, because it doesn't cost you thousands or tens of thousands of dollars. It cost you maybe a few hundred. And that is the game-changing thing here.
Very good. Okay, let me get this back. Now, let's talk about robotics in general again. You mentioned that this industry is really evolving day by day. Where do you see this industry, the robotics, in 5 or maybe 10 years? I don't know if you can say 10 years, but in a few years at least.
Yeah, so I think the most exciting point of that is that when these robots, these general purpose robots, are starting to get out there and that's not, maybe not even general purpose, maybe the key is versatility itself. When we are able to already manipulate our environment, and when these robots enter the playing field in our human environment as well, not just on the factory floor really, that I think is the most important and most exciting shift, because then it suddenly is no longer just about dexterity and manipulation technicalities, but also our feelings related to it. And by that I don't just mean like not it becomes something of so much of a consumer product that it's not just related to technical people and the technical crowd. It relates to the common folk, and that is the most exciting part of how do you make something so complex technologically and something so difficult to develop and so difficult to fit technically in the environment, also fit psychologically and also fit into the consumer scene. And I think we are going to start seeing that in the next couple of years, and then it's going to bring its own very, very complex space and so many exciting problems to solve.
So you basically say that robots became a mainstream, or will become a mainstream
in one way or another. So it remains to be seen how, but yeah.
And this is the question, that how. So for an average person point of view, how you can imagine that in an average person lives it will appear in every day?
So I definitely think that there are use cases where it becomes useful sooner than later, but in some sooner, in some a little bit more later. In terms of assistant robots, I definitely see a huge value. Basic example, everyone's seen the movie Iron Man, when there is a robotic arm on Tony Stark's workbench, and that is something that would be hugely useful for various R&D activities, and it's one of my personal points on my agenda, is that I want to have a robotic assistant helping me assemble things, helping me work. It's a physical embodiment to the AI assistants we create for ourselves today, and that is something that is only possible if we can really trust it. And that is usually the general problem with AI system and large language models, is that they tend to hallucinate a lot. The trust issue is definitely there. You opt for reducing the chance of misfiring as much as possible, but it's never going to be completely eliminated. And for that reason, you want to create hardware that is as safe as possible, where I can feel safe even if something happens which is maybe not the most, maybe a jerk of a movement or something which is not expected, and maybe a misinterpreted command or whatever. And integrating those type of assistant robots in our environment is something that I think it's probably one of the most important and exciting parts of the next field. Because when it happens in the factory floor and automation, when dexterity becomes something in complex tasks that is definitely achievable and possible, then it will start to be applied in scenarios which are much more closer to human environment as well.
And in your opinion, what are the most overhyped things in robotics these days? Which sounds really cool, but maybe in 2 years they will...
I think so. While I'm a big supporter and admirer of the humanoid scene, I do think that the complete generalization is a bit overhyped. So I do think that there are some companies already showing that even within the humanoid form factor there are specializations. And I think that while the notion is true that the humanoid form factor is great for environments which were built for humans, I think it's an overkill to completely generalize all the problems, because it's simply more effective and better. So even me with my human hands, it's fully generalized and I can do a lot of things, but I'm not so effective in a lot of them as I could be if I had a little bit of a different tooling. And with robotics, we can do that. So why don't we do that? I definitely think that the winning point is somewhere in between specialization and generalization. And I think that is something that is still in the early, because I get the point that first we need to be able to generalize in order to then start shrinking again. But I think that is the way to go, and complete generalization will not solve every problem out there.
And are there any new technology or solution that is a bit underestimated these days, but could be a really big value for the future robotics?
I think a lot of them. So this type of physical AI push is definitely shooting a lot of different technologies to the forefront, which can be integrated and highly useful. I think soft robotics is actually one of them, and the ability, and that is why we are also targeting this in a sense of the ability to combine what's already there, a lot of advantages in soft robotics, and make that something that is no longer considered this niche, but is more integrated in everyday robotics by creating these hybrid structures as we do, is definitely one of them. And in those cases, a lot of new sensor technologies and actuation technologies like artificial muscles are maybe may be able to shoot to the forefront as well and become something that is useful.
Wow, it was really interesting. Thank you, Benedek, for your time.
Thank you so much.
It was nice to see you, and see you guys next time.